So for this week on CyberSchool, we're covering kind of a basic topic, something that I just kind of figured now that we've really kind of gone over a lot of our products in kind of a depth and what they do, how to use them, and how to apply them, but we've never really talked about actually setting these things up and best practices when you're kind of going through and implementing these CyberData products. We'll be talking strictly about actual configuration settings, not so much like installation, that in that regard, mainly more settings, and just kind of doing a deep dive on how you should set stuff up and what some of these settings mean, because that might not have been clear from some of the other videos that we've done. So with that, how should a CyberData device be set up? Well, it really kind of depends on the particular phone platform that you're going to be using it on, or if you're going to be using it on a phone platform for that matter. But generally, it's going to be really platform dependent, meaning that, say, for example, a Cisco call manager setup or a 3CX setup is going to be vastly different than, say, like a Zoom phone system setup. And that can be things like, what SIP transport is going to be used. And that's actually how the SIP messages and what protocol the devices will use to actually send those SIP messages from point A to point B. Point A being your CyberData device and point B being your server of choice. And then, what are some of the other settings you'll see on that page? What the heck is a keep alive? These things they're electronics. They're not alive. What's a keep alive? And then, what settings are actually necessary? So hopefully we'll cover that in the scope of today's CyberSchool. So for a basic SIP setup, you'll first want to start with, of course, your SIP transport and your credentials. Your SIP transport is really going to depend on the particular platform that you're using during the configuration. And the screenshot that I have on the right side is a little bit adjusted for those support guys that are probably saying, hey, that's not what it actually looks like. I adjusted it to make the, make the screen look a little bit better, make it more visually appealing. But, generally when you're dealing with credentials that are provided from your SIP provider, you really can't change that. They set the name of their server, they set what your user ID and your auth ID are and your password. So you really just kind of have to take that information at face value. There's nothing you can really adjust there. But things like SIP transports vary depending on the particular platform. UDP is still the kind of industry standard in terms of, getting those messages from point A to point B, but more and more hosted providers are supporting what's known as TLS, or Transport Layer Security, where they'll actually use a method of encryption to send the messages between point A and point B, which is just, in today, in 2021, you would think, okay, everything is encrypted when it's sent. Actually, that's not how a lot of things work in networking and computers. Most of the stuff is sent in plain text, with that, being kind of a larger change for using encryption more in, the last 5 or 6 years. It really kind of depends on what you're working with. But in terms of SIP, most platforms, even supporting TLS, is still pretty recent, being, kind of a little bit more used in the industry in the last probably 2, maybe 3 years or so. And it's really going to become more of a standard as more and more platforms are moving to a hosted or a cloud-based environment, meaning all of those SIP messages, who you're calling and who is calling you, is being sent over the open internet. More and more of that is going to be encrypted. So TLS is going to be supported more and more, but it really kind of depends on, at the end of the day, what your platform supports. They really dictate what transport you're going to be using. So it's really kind of up to them. If they're doing UDP, great, that's all you can do. If they're doing all 3 options, UDP, TCP, and TLS, then you can pick one of those. TLS is usually better just because everything is encrypted, and encryption is always better because that way people can't spy and see who you're calling. But, it again really just kind of depends on the particular platform. And then the other thing that is typically adjusted in base setups is just going to be the registration interval. And that is, in a very literal sense, the re-registration. That's how often the device will check in with that particular phone server to just say, hey, I still want to be registered at, like in this example, this is a SIP device at extension 100. And for this, it's set to check in and re-register every 30 seconds. That's going to be our minimum. Our default is 360 seconds. And generally, that's good on most platforms. Most platforms really don't mind in the SIP protocols. If you really want to get, if you want to put yourself to sleep, go through and read all of the SIP RFCs that denote the rules for SIP. The SIP servers, the phone platforms that you work with, can actually go and negotiate what that re-registration interval is. Say, for example, we're set to 360 and that's too high for them and they want you to do, say, 120 seconds. They can force the device to re-register every 120 seconds. So kind of like your credentials, what the SIP server says goes. They're in charge. It really doesn't matter on most platforms whether or not you're using, say, our default, the maximum of 3,600 seconds, or the minimum of 30. It really kind of depends on the platform. Although, with that said, some platforms do definitely perform better with a short registration interval. During this testing, like the screenshot, instead of just reconfiguring it for a different system, I set it up and just used our setup for Core Dial, which I found it operated a little bit better with a low registration interval of 30 seconds, just going for our minimum. Another key example that we use this low registration interval is Ring Central. But some other platforms like 3CX, 360 seconds is fine. I mean, heck, you can go for 3,600 settings. 3,600 seconds. You can literally let it go and re-register once an hour. That's fine. It really kind of depends on the platform and the stability of the network, but generally the default is good enough. So as we move on, another thing that you'll see on our SIP page, which you'll see a little bit more illustrated in the second in my next slide here, is going to be the backup servers. And backup servers help build in redundancy to our products. Just because when you're thinking about your phone system, you think, for example, it's an emergency situation, just dealing with your cell phone, not even thinking of, your business phone system. If your phone doesn't work, it's probably going to be able to connect to one cell tower or a different cell tower. There's going to be many different cell towers for your cell phone to work with. And that just builds that redundancy. So that way, in the event that they take down a cell tower because, somebody, it's a 5G tower and, somebody who's taking pot shots at it or something like that, or, just general maintenance, your phone will just go over to a different cell tower and continue to work. It's got that built-in redundancy. And your regular SIP business phone system should still have that redundancy. It's super duper important with phone systems, just like you would expect it with your cell phone. You want that for your business system. And there's two real ways to go and implement this backup or this redundancy. And the two ways that are done are either what's known as kind of a cluster style, where you've got, basically 1 to 3 servers, one being the only one. And if that fails, you're, SOL, or 3 being, one primary and 2 backups. And that's kind of a cluster style. Cluster styles were a lot more popular in kind of the early days of VoIP, back when, frankly, a lot of people weren't using it. And it's mainly only used today by Cisco Unified Call Manager or Cisco Call Manager or CUCM. It's got a lot of different names, or just Cisco, where that's where the device will actually register with the primary and the backup servers. And in the Cisco world, they refer to those as publishers and subscribers. And that's kind of one way to do it. It has some advantages and some disadvantages. Advantages are that, it's basically all managed by you. When you're doing anything with Cisco Call Manager, it's typically on virtual machines that are, in your server room somewhere, and they just work. But, when you're dealing with something like, say, Zoom or Ring Central or any of the, the other handful of hosted providers, instead of doing a cluster system where you got to, configure 3 different extensions on there, that's a little difficult. They do what's known as DNS-based redundancy, where the device will do a DNS lookup, a domain name service lookup on the actual address, the fully qualified domain name of that primary SIP server. We'll see it again illustrated in our next slide here, where the redundancy is just built in. It kind of happens automatically. It just works. It's just something that happens transparently in the background, where if one server fails, it does a lookup, it finds a different server, and it's completely transparent to the user. They don't configure any backup servers. The system just doesn't go down, because if the system goes down, it just points to a different record, and the thing just works. Just to steal, my favorite thunder from one of my favorite developers, Todd Howard, it just works. So with backup servers, here's a good screenshot that kind of illustrates everything. And this is really focusing on the cluster style setup. And this is mirroring kind of what we would do if we had the cluster actually set up in our offices at CyberData. We've got, a single Cisco server. We don't use it for our phone system. It's just basically for testing. So we don't have to implement redundancy because you don't need redundancy built into a test server. Probably be good to test it there, but we can test, the redundant backup on different platforms. But the way that this will work is your primary SIP server, illustrated up here in the top, that's going to be the main server that you'll always work with. So say, for example, you're configuring Cisco Call Manager, your primary or your publisher would go up here in the top. Or say, for example, Ring Central, this is the only one you're going to configure. But focusing on the cluster setup, we've got, of course, your primary, your publisher node set up as your primary, and then backup 1 and backup 2 are going to be those two subscriber nodes. And in this type of environment, as you can see down here at the bottom, we're requiring the special setting here, use Cisco SRST. And what that does is that changes how the devices will actually go and register with the Cisco server. Now, when you've got a primary and backup servers configured without Cisco SRST enabled, we're going to try to register with the primary, we're going to try to register with the backup and the other backup. We're going to try to maintain status on all three of those servers, saying we are going to be extension 123 at these three different servers. And in the Cisco world, that can cause a little bit of confusion because the Cisco world kind of works in a cluster style where it'll say, hey, 123 is getting a call. And then the servers say, hey, I'm the primary and then I'm the backup. They're both registered here. Who makes the call? And then the Cisco server doesn't really know what to do. And sometimes the calls won't connect. So that's why you need the setting Cisco SRST. And what it does is it's a slight little adjustment to the actual registration process when we're going and registering with the primary and the backup servers. With Cisco SRST enabled, we'll maintain actual registration with our SIP server here. So let's just say, for example, we're going through and we're doing our registration process. So we'll send out a register to say, hey, I am, this device. I want to register at extension 123. Here's my username. I am CyberData, and here's my secret password. And I'd like to be registered at extension 123 for 360 seconds. And we go through this little handshake process where Cisco says, hey, give me your password. And we're like, okay, cool. Here's my password. And Cisco's like, okay, you're good. You can register for 360 seconds. And then we move on to the backup ones. But because we have Cisco SRST enabled, we go through that same process. We try to register to the address 10.11.11.35 at number 123 with the username CyberData and our super secret password. But instead of saying we want to be extension 123 for 360 seconds, we tell them we want to be extension 123 for 0 seconds, commonly known as an unregister. And what this does is this just tells the server, hey, I want to register there, but I don't actually want to register there. I basically just want to make sure you're there. So we'll go through that same handshake process where we'll try to register at extension 123, and it'll say, give me your password. And we give them the password, and they're like, okay, cool, you're registered for 0 seconds. Okay, time's up. And what that does is that just lets us know that the server is there and it's available in the event that the primary stops responding. The primary server, say, goes down, there's a, catastrophic drive failure and the whole system is down, then we just default over to the other one. Or in a less catastrophic manner, say they just take it down for maintenance, then backup 1 and backup 2 will come up. So in the event that something like that happens, we try to register again to our primary and we say, hey, we want to register for 360 seconds. And we send that request and we get crickets. And we try it again and more crickets. And then we try that 8 more times for a total of 10 times. And if that doesn't happen, which takes around 30 to 40 seconds or so, then we'll say, okay, the primary is down. We'll go over to backup number 1. And then we'll register at backup number 1, 10.11.11.35, saying, hey, I want to be extension 123. But instead of registering with an expiration of 0, we register with an expiry of 360. We take the full time and say, hey, 1135. We want to be extension 123. And it's like, okay, cool. Give me your password. And we're like, hey, great. Somebody's responding to us. Here's my password. And they're like, okay, you're good. You're there. And everything functions as normally. And this is completely transparent to the user as long as they're not trying to make a call to the device in that, 30, 40-second window of that failover. So with Cisco SRST in the setup, it makes these cluster style registrations actually work in a Cisco environment. And this kind of setup is it's really getting aged out as a lot of different localities and different actual companies, they're getting away from using Cisco. Frankly, just because Cisco is really expensive. It is extremely complicated to go and set up. There's a reason that Cisco wants you to take classes to earn certifications to, not only set up their switches and their routers, but their phone systems. There's a reason for that. Their stuff is really complicated. You can do a lot of cool stuff with it, but it's really complicated. And at the end of the day, it's also really expensive. Cisco is a brand name. They've been around in computer tech for, oh my gosh, for ages. So, their stuff has a high price point, just like, you're buying an Apple, you're buying a Tesla, you're buying a Gucci bag. It's probably as good as, all the other stuff out there, but there's that name, that label on it. So that just kicks up the price a whole bunch more. So a lot of people are getting away from this cluster style because they're moving away from Cisco Call Manager. And more people are switching to hosted providers, which use DNS for their redundancy, which again is completely transparent to the users without going into the whole depth of how this works underneath the hood. This could literally be a whole nother CyberSchool talking about DNS-based redundancy. Maybe we'll do that if you guys really want to get bored. But basically what it does, we just do a lookup. So instead of having our IP address here, we got a good comment here chiming in. Okay. No, that's weird. Said we had a comment, but we don't have a comment. Okay, never mind. Back to it. So for DNS-based redundancy, let's pretend that instead of this IP address here, we had, say, sip.com. Let's start super duper simple. And sip.com points to, when you look up that address, it says, hey, sip.com is it, say 10.11.11.34. But it's also got 10.11.11.35 and 10.11.11.36. But use 34 first. And that'll all happen transparently to the user. And in that same kind of sense, where if the primary stops responding and we switch over to the backups, the same thing happens with that DNS-based redundancy, but it's completely transparent to the user. It can happen a whole lot quicker, and they don't have to deal with that extra configuration, because one of the pain points with Cisco Call Manager is getting the configuration that you do on the primary server, your publisher node, to actually push over to the subscribers. There's a little bit of time in between. You've got to click some special buttons. So it can be a little bit cumbersome. There's steps you got to remember so you don't screw everything up, where DNS is completely redundant. You don't even have an idea it's working. It just works. So that's kind of how you set up these backup servers. This is a little bit more of an advanced setup if you're going to be doing something like this, but this is something that could be involved in one of these basic setups. So as we move on, there's some additional other SIP settings that sometimes you can run into and you can actually go and change. For example, the keep alive period. I mentioned that earlier. What's a keep alive period? Well, a keep alive period is basically the period of time where we send basically a dummy message, where it's literally what's known as an empty packet, and that's just, data being transmitted across the network. Don't think about it too much. It's not a packet, it's not a little, yellow manila envelope or anything like that. It's just a networking term. But we send an empty packet by default every 10 seconds to either the primary SIP server or the outbound proxy. And that's basically just to make sure all of the ports are open. We can maintain contact with that. It was really kind of like to go through all the history of it. We implemented it to kind of deal with some problems with servers, where if the port wasn't always, if the port wasn't in constant use, it would get shut off. It also kind of coincided with something that a lot of switch manufacturers were doing in the early teens, 2013, 2014, where they were putting this green mode, air quotes, on all of their switch ports, where if the switch port was kind of inactive, say, you've got your regular desk phone and it's plugged into the network and it's 10 o'clock at night, nobody's using that phone, it doesn't need to use all that same amount of power that it would, say, at 10 o'clock in the morning when you're getting calls off hook. We're getting a whole bunch of calls for different orders. They want to check on the status. When's this shipping? Your phone's using more power then, but in the middle of the night it's not using that much power. So all the switch manufacturers were like, hey, let's implement this green mode. Let's go down to the bare minimum amount of power. So that way we save power. The switches use less energy. We're green certified. There was probably some, government cheese they could get by, meeting those Energy Star standards, all that good stuff. But that caused problems with, not only our equipment, but a lot of other equipment manufacturers out there, because they weren't always able to wake up that port to request the full power when that emergency came up. They get this emergency call, and the device is like, hey, switch, give me some more power. And the switch is like, it can't understand it. So that became a problem. So we used the keep alive period, basically just sending traffic every 10 seconds, where the switch is like, hey, that port's in use. I'm not going to switch that one over to green mode, which was all well and good in, a regular premise-based system where there's not really a whole lot going on. It's all on the same local area network. Nothing's going out into the cloud. But when people started switching over to the cloud, that started to cause problems, because there's this other piece of equipment that is commonly used by cloud providers called an SBC, a session border controller, commonly used with Teams. We've talked about them a lot with Teams integration, but that can cause problems, because basically what the session border controller is there to do is to control the border in between all of the devices that are trying to talk to the SIP server and the SIP server or that phone system, just to be able to prevent all the noise, the people that aren't supposed to be able to talk to that phone system. It kind of, stops them there at the gate. It's like the doorman that we've all seen at those, different movies of, them in New York, where, they got the door guy standing there, and this, kind of weird guy's walking up trying to ramble, and door guy's like, hey, get out of here. You don't belong here. That's basically a session border controller in a sense. But our standard message, our keep alive period that we were sending every 10 seconds, the session border controller was like, hey, this thing's supposed to be using my system, but it keeps sending this traffic every 10 seconds. I don't like that. You're going on the blacklist. You're going on timeout. So they stick the device over in the corner for 10 minutes or so, and they just stop responding to it. They're on timeout. Nobody's going to talk to it. Which, when you're dealing with paging equipment, potentially stuff that's giving out, say, a tornado warning or a fire warning, that's unacceptable. That stuff needs to be up all the time. So in that sense, and commonly with Ring Central is the big provider that we have this particular issue with, is we'll recommend that the keep alive period actually be disabled by setting it to 0. So that way we're not spamming that session border controller, that doorman at the hotel or the apartment building, with that, constant barrage of traffic. So that way when we get that call or we try to register, they're like, oh, hey, you're supposed to be here, and the doorman opens the door, the traffic is allowed to go through. So the keep alive period can really cause a lot of problems in hosted environments. So generally, we kind of recommend disabling it in hosted environments. It's not, that's not a blanket statement where, just disable it. If it's hosted, just disable it. It really kind of depends on the platform and how they have everything set up. But any of the flavors of Ring Central, so Ring Central, TELUS, Office at Hand, via Office Cloud, basically anything that's set on Ring Central, we recommend disabling it. As we move on, we've got a setting that's kind of a misnomer called Disable RPort Discovery, and you have to enable this. So it's kind of a misnomer. You have to disable RPort Discovery. It's kind of a misnomer, but frankly, there's no better way to name it. But what this does is it's basically, again, this is another thing that I could spend like an hour talking about. It's basically just having the device, when this is not enabled, meaning that it is disabled, again, misnomer, when it is not enabled, the device will actually send out a registration request to hosted providers with what is known as a wide area network address, your public IP address, what you're getting from Comcast or from Spectrum or, Dish or, what have you. But that can cause problems in environments where they're using that session border controller, kind of like we were talking about with that keep alive period. Although you don't need this for Ring Central, that would be more local-based SBCs, or what's known as SIP ALG, or SIP Application Layer Gateway. And basically that's just like a fancy router or an SBC that actually goes in there and changes the SIP packets as they go through. really you don't need to disable the setting. Commonly, when you do need to actually disable airport discovery, is when you're having some kind of weird operation with your equipment. I've found in my network here at home, I need to actually use this, even though I have SIP ALG turned off on my router. I find that my devices will respond a little bit better. And the way that the problem can manifest is either the thing just won't work, it won't register, even though you've gone through and you've checked the password, your password's right, you're slamming your head into your keyboard, you can't figure it out. Sometimes you're not the problem, your router's the problem, and you have no idea about it. So by enabling disable airport discovery, that can fix the problem. That wasn't happening in my case, but I was just conveniently missing important messages. So things like the call actually getting answered, or what's known as an acknowledgement to a call. Again, stuff that I really don't need to talk about for this, but it can kind of manifest in weird symptoms. So my main recommendation to support when we go and we have to try this, try it. If it fixes the problem, great. If not, just turn it back off. Disable airport discovery. Again, kind of a misnomer. And then the last one that we'll get to, and these are again, these three are kind of specialty SIP settings that you only really need to adjust if, in very rare settings. And the final one is jitter buffer. Jitter buffer, frankly, in my near 5 years with CyberData, I've never actually had to adjust the jitter buffer from our 50 milliseconds that we use. And again, this is another setting that I could literally spend an hour talking about, but a jitter buffer is basically just an extra period of time that the device allows different messages to come in. Because of the nature of the protocols that we use, stuff can come in out of order, where you're having a phone call with somebody and you're saying something. Well, you would think that audio would be exactly what they said, but the way that it's actually transmitted, stuff can get mixed around, which kind of doesn't make sense. It seems kind of weird, but that's one of the things that can happen with network jitter when you're dealing with protocols like UDP. Again, I think I've got a CyberSchool on that. Really boring subject. We don't need to go into that today. But jitter buffer is something you don't really need to adjust, but in rare circumstances, say you've got a super busy network, you can adjust it. But in all of my time at CyberData, I've never had to touch that setting. So I don't even know of a circumstance where we've actually had to adjust it. As we move on, another key thing that can get set up is multicast. And multicast is just, again, I've got a whole nother CyberSchool on multicast if you want to go into the depth of it. But our products support 10 different multicast priorities. And these are just IP addresses and port combinations that our devices can listen for pages at. It can be, I don't need to go through all the different examples of it, but it's basically just, addresses where we're always listening for essentially a radio broadcast. And we've got 10 different priorities or addresses that we can listen to, and they're ranked in a priority system where, of course, higher priority supersedes a lower priority. And a SIP call, just, picking up, dialing extension 123, that's going to be treated as kind of that middle of the road priority 4.5. So it'll supersede priorities 0 through 4 and be superseded by priorities 5 through 9. It's always good practice to go and set your mission critical messages, stuff that you don't want to get missed, to that high priority, where no matter what, you don't want anything playing over that tornado warning. You don't want, that really great, song on background music coming over that emergency warning that, there's a tornado coming or a tsunami or something like that, or, a deadly gas being vented on, part of the building. You don't really want to, kind of mess with those mission critical stuff. So that should always be at your highest priority. We'll kind of go into that. I illustrated in the next slide. But stuff like background music, stuff that frankly isn't important, you're just using your speakers because you spent all that money on them. You might as well have sound coming out of them all the time. Use that investment. Stuff like that, background music, stuff that's not really important, should be low priority. So anything that would be more important plays over that. So as an example, we've just got, this is taken off one of our standard SIP speakers, but priority 9 is going to be your highest priority. And one key little thing with priority 9 is we treat that, and it's labeled as, emergency warning. That one is, not only labeled in kind of my example here, but we treat that one literally as emergency. And that one operates a little bit differently than all the other priorities. I mean, of course, it's going to play over everything else, but where it operates differently is it will play at max volume always, regardless of how you have it configured. So say, it's kind of like it's a library speaker. It's pretty quiet in the library. They don't need to have the speaker cranked up very high. Maybe they have it at our default setting of 4. Maybe they really turned it up and they went up to 5. Regardless, if an emergency broadcast comes through at priority 9, this address and port combination, it will play at max volume, no matter what. There's no way to disable that. By design, we don't want those emergency warnings to get missed because, say, for example, with our SIP speaker that I took this from, we've got that analog scrolly volume wheel. And if you leave that, in an unsupervised classroom, say a full, middle schoolers or high schoolers, they see a wheel on there, they're going to scroll down that wheel. They're going to mess with it because, it's something to touch. So in the event of, a teenager being a teenager, we don't want that, fire warning or, fire drill, earthquake, or God forbid a shooter on campus. We don't want those types of messages to get missed. So priority 9 will always play at max volume, no matter what you do. There's no way to disable that. This is how it works. If you don't like that, don't use priority 9. But in our example here, we're using it just like for that. So emergency warnings are always going to be top priority. They'll always play over everything else, and they will always play at that max volume. Then we go down to your all page, your all call, but your non-emergency stuff that, is an emergency, doesn't need to be blasted at max volume. But it's like, hey, everybody, we did really good on sales. We're having a taco party out back. Dave's got margaritas, Elio's making tacos. Let's go have a party, everybody. We met our sales goal. Everything went good. We shipped thousands of speakers. Done deal. That one doesn't need to be an emergency, but you want that to go out everywhere. So that's where priority 8 comes in. That's going to be your non-emergency all call. Then we've got priority number 7, which is just going to be your warehouse only area. So say, for example, and let's say this is a CyberData speaker. Heck, I was kind of doing it. Let's just go full on. Let's say Dave is trying to have his morning huddle. He's trying to talk about, okay, we need to build this many speakers. Oh, we're kind of low on this. Let's do that. Okay, do you guys have anything else we want to work on? Did you get all this finished or that finished? He can make that announcement saying, hey, guys, we're going to have our huddle in 5 minutes. Everybody meet out there on the production floor. Get your coffees. Come back from your smoke breaks, what have you. That way, the page only goes to the warehouse. So, the guys that are actually out there on the production floor hear this, and they can, plan accordingly for that. While, Alan and all the rest of the sales crew, they're dealing with their phone calls. They don't need to know when the production crew's having a meeting in 5 minutes. It doesn't really matter to them. So that's why that page doesn't go to them. Then we deal with all of our other kind of middle of the road priorities here, all just kind of illustrated as not used because they're not used. But then finally we get down to background music down here at the bottom. So the guys want to jam out, they want to listen to some music as they're working, all well and good. Music can improve productivity. So Dave's piping through some background music for them, of course at priority level 0. So that way if they got to make an announcement to the warehouse, all the different announcements that they'll need to make will be superseded and will play over that background music that's just jamming out there. It might come in the middle of a song that might kind of suck for everybody. They might hear a page come through and be like, oh, that was the best part. Sorry. That's just kind of the way it works. But as you'll see, we've also got a couple columns on our right-hand side for additional things that the speaker can do when that page comes through. So we've got settings like buffer, beep, and relay. What buffer does is it will actually record that page. Of course, it's not available for emergency because emergency is live. You don't want any types of recording preventing that emergency recording going out. But what buffer does is it will basically just record that announcement. And then when the announcement is finished, it will play the announcement. And that's really convenient in areas, say, for example, Dave is making that page to, get everybody out on the warehouse, get everybody out on the production floor. But he's making that announcement right by a speaker. And if that was live, whatever he says, and you might have heard this, as you go around and you're shopping at, Kmart or Target, and they're making those announcements, hey, 6 feet distance, wear your mask, what have you. That's always delayed. If you've ever seen somebody actually making that at one of the checkout lanes, they go, they pick up the phone, they dial the numbers, they say what they need to, they hang up, and then it plays. Because if that's not buffered, as soon as they start talking, it's going to create a feedback loop and blow out everybody's eardrums. So that's where buffer comes in. Then we've got beep, which is just a pre-page beep tone, where that page comes in, and before that comes through, it goes beep. So that way everybody knows that, hey, there's an announcement coming through. Stop what I'm doing. Pay attention. You know, that kind of stuff that you're used to with any kind of paging system. And then finally, we've got the relay, which just activates the onboard relay. That can be useful if you're tying in, say, the speaker to, say, maybe not a non-CyberData strobe. Instead of having, you know, one of those blinky LED strobes like we do, that you could, of course, connect with an accessory kit to one of our speakers. But say, for example, you want one of those cool old school whirly-bird strobes, you know, the stuff they used to have on cop cars back in, you know, the cool old movies, you know, where they spin around and they got the lights on there. So you've got it connected to that. We don't make one of those, but it's got a sensor input on there that can be triggered by a device with a relay. So you can just check the box for that. And when we get that page for, say, the warehouse, that'll click our onboard relay, the circuit will close, and that whirly-bird strobe can kick on and start blinking. All, you know, completely transparent just based on the settings there. So that's kind of how you would set up multicast. Again, this is a pretty basic setup for multicast. As we move forward, we've got other things on the product called sensors. And, you know, what the heck? You got sensors? Well, we've generally got 1 to 2 sensors on our different devices. Generally, we've got one that we call the door sense, which is basically just an input sensor or a door sensor that when the pins are shorted together by a relay. So to step back, we've got, you know, we've basically got a relay on our device. And we'll kind of cover that more when we get to intercoms, and you can enter a DTMF code or, like in our previous slide, check a box so that way when we get a page, the relay triggers. All that is, it's basically just like a, you know, it's just, you know, like a relay closes, kind of like a light, you know, you flip a light switch and the circuit is completed. The system can detect that happened, and whatever we're connected to can take some kind of action. Well, the inverse of that would be a sensor, where you've got 2 pins that when those 2 pins are shorted together, either, you know, literally by like a paper clip, or in the event of, say, like a fire panel that would have an onboard relay that could trigger when somebody pulls a fire alarm, triggering one of our devices, you can actually go and utilize those sensors. So one of the most common use cases that we have for these are going to be for a door sense, and that's going to be with a magnetic door sense. You know, if you've ever had, you know, like that ADT, you know, those different like home security systems, you know, you can know when your front door opens because you've got that, you know, that little white box that's at the top of your door. Well, that's a magnetic sensor, and you can tie those into your CyberData intercoms where, you know, you go and you set that up and you tell it, you know, what state the intercom's normally in, and then you can set up the device to take an action when the sensor gets outside of that range for a particular time. We've also got more commonly used a sensor, an intrusion sensor. Basically, this is going to be a tamper sensor. What it is it's an optical light sensor, and this is only featured on our intercom products. Frankly, the only stuff that would really warrant anything like this, say your outdoor intercom, well, you would kind of want to know if somebody goes and takes the screws or those security Torx bits out of your intercom and tries to take the intercom off the wall. You'd probably like to know about that instead of, you know, coming into work the next day and your intercom's missing, or, you know, God forbid, you know, your roll-up doors are open and all your equipment's gone. But that's where this intrusion sensor comes in. It's a little optical light sensor that we've adjusted where if the front panel of the intercom moves about ½ an inch from its regular mounted point, that intrusion sensor is going to trip. And just like the door sensor, it can take some kind of action based on that particular activation. You know, it can do whatever you like. So with that, what the heck can these things do? And while I'm illustrating the sensor input here, the intrusion sensor works virtually identically. You know, there's basically the exact same settings that you can utilize with it. It can take the exact same actions. It's basically just called a different thing. So for the purposes of this video, we're just going to go over the regular sensor settings, but regardless, both the intrusion or the door sensor work in the exact same fashion. So when you're setting up one of these sensors, and this is the one setting you don't do for the intrusion sensor because we handle that part for you. You don't have to deal with that. But say for like a door sense, you have to tell the intercom what that status of that sensor is. Is the sensor normally closed, meaning should this door always be closed, or is it normally open, meaning the door is normally open, and if it's closed, do something about it. So then you've got your next setting, sensor timeout. And that's just, you know, okay, so the sensor has changed state, meaning, yes, the door is normally closed, the door is open. well, how long should the door be open before the intercom does something? Because say, for example, it's like a back door. That door, might be able to be open. Maybe the guy, maybe there's a parking lot right there and it's used for, employees to come in and out. So, maybe that door is allowed to be open for, say, 15, 30 seconds. But if it's open outside of that window, the intercom can take action based on that. And the actions that it can take are pretty simple. It can either activate its onboard relay. So say, for example, kind of like in Dave paging to the warehouse, they've got it connected to a strobe. After 30 seconds, the relay can activate and the strobe can start, it can start blinking above the door. So that way, somebody that's walking around sees the strobe flashing above the door. Hey, why is that going on? Oh, well, somebody's got a rock in the door. They got it propped open. It's hot. Okay, not a big deal. You close the door. Hey, guys, we can't do that. I'm sorry, it's hot. You just got to deal with the heat. Something like that. The intercom can also play audio locally. So it can just say, door ajar, door ajar, door ajar. So say, for example, you don't have one of those nifty automatic door closers that's on there, and somebody just forgot to close the door. So you go close the door. No big deal. Or you can have it make a call to an extension. So say, for example, and like the illustration that I have done here, you've got your sensor settings, and this is done from a speaker. I just had my speaker out when I was designing all this, so I just took it from a speaker. So you've got a smoke detector that's got an onboard relay on it, and it can go and trigger its onboard relay when it detects smoke or maybe vape. And it can go and call a predetermined extension. So the sensor goes and the sensor is triggered and it says, okay, what do I do? I'm going to play some audio locally, and I'm also going to make a call to extension 123, and my caller ID is going to be smoke detector. Now let's just say, for example, this goes to the front office of a school and they say, oh, hey, the smoke detector is going on. We've only got this in the one bathroom. Let's go into the bathroom. And lo and behold, they catch some, teenage delinquent in there, smoking a cigarette or something. So, there's a lot of different applications for that, but this is commonly how you would go and use our sensors, whether they're the intrusion sensor or that sensor or the input sensor, depending on the particular product. And again, there's a lot of different variations of these, but they're all virtually the same. They can basically play audio locally, they can close their relay, and they can make a call and play that preloaded audio file. So you've got a lot of different options when you're dealing with these different sensors. And when people get into, they're using their SIP setup, their multicast, their sensors, this is a pretty complex installation. We don't honestly come across many installations that are using this many features of your product. That's real advanced. That's your real CyberData super user. But then we get into some device-specific settings. So these are all going to kind of vary between different devices. Say, for example, with our intercoms, key device settings that you're going to want to adjust are things like the DTMF pattern. So that's like, say, for example, the DTMF tones that would use to remotely unlock the door by entering these DTMF tones, or basically just, buttons on your phone keypad to actually go and trigger that door. You can also, if you want, I don't know why you'd really want to do this, but you could disable the auto answer incoming call on intercoms, which is just kind of a key feature. You've got that capability in there. We'll go into more of these settings in depth momentarily. Then for stuff like our paging series, we've got two key settings that we use a lot. Activate relay on local audio, which just means, when a paging series device or paging server or our SIP paging adapter get a call, they can trigger that onboard relay to usually just work with that amplifier that we're working with. And then another setting that we use a lot is bypass DTMF menus. And when you call either of our paging series devices, the paging server or the paging adapter, you'll get some kind of, auto attendant message that'll say something along the lines of, enter your 2-digit zone code, or press 0 to page and press 1 through 9 for stored messages. Sometimes people don't want to hear they don't want to press that extra button. They're kind of lazy. They just want to call extension 123 and make that overhead announcement to say, there's a special in, this lane. They got, canned soup on sale or something like that. So that's a setting that we'll run into a lot. Other kind of device specific settings are volume settings. Frankly, not all of our products have volume settings. But then another key one, in addition to volume settings, is stuff like disable the volume dial, because, teenagers will be teenagers, and if there's a volume dial to adjust, they'll try adjusting it. So you can disable that. So as we move in, let's talk more about the paging series and the settings that are featured on their device tab. Just to kind of go through the individual settings, we've got line in settings, which just handles all of the audio input. We've got a line in on both of our paging series devices, the paging server and the paging adapter. And if you want to use that line in, you have to tell it, okay, where does it go? Do you want it to go from line in to line out, basically just to loop it? Or if it comes into line in, it goes right back out to line out, don't do anything with it? Or maybe by chance you want to multicast that. You want to send that out to all your fancy CyberData speakers. So you can set it to line out to multicast, and then you set that multicast address, which would be that background music from a few slides ago, just to be able to set that there. And then finally, detect line in silence. So that way, when there's nothing being sent through the line in, it's going to stop trying to transmit it. So that way you don't get that kind of hum from your analog amplifier. As we move to the right, we've got our relay settings, and there's only one setting for our paging devices: activate relay on local audio, which just means anytime audio comes through the paging server, which would be line in, or SIP call or multicast in the eyes of a paging adapter, it can go and activate that local relay, and it'll just say, okay, hey, I'm getting audio, trigger my relay, which is really only used with analog amplifiers, because some analog amplifiers require that DTMF relay or that relay contact closure to say, hey, there's a higher priority message come through, I'm going to play that message. So that's really all how those are used. As we move to our bottom left, we've got our clock settings, which on some products really aren't super duper necessary. You don't really need to. Your 4-port zone controller really doesn't need to know what time it is. There's no settings on there that actually impact time. However, as we've added more features to our products, and especially for things like the paging server, when we've got a bell scheduler and scheduled events built into it, if the paging server doesn't know what time it is, those bells are going to go off at real random times. So having clock settings enabled are super duper important for certain devices. And for paging servers, it's absolutely critical to have your device actually get the right time, so that way your messages go off when you program them to. Kind of a no-brainer with stuff like that. Then finally, we get over to miscellaneous settings, which are really kind of device-specific settings. They kind of allow you to enable or disable features. So things like bypass DTMF menus that we talked about in the last slide are there. Or if you would like, a general beep on init, which is just, basically beep on power up, or a beep on page, and that's a global setting, you can actually go and set that there. But then we've got other stuff like enable Polycom paging if you're using Polycom, formerly Polycom, now Polyphones, or if you're doing, if for some reason you want to disable HTTPS for your web interface. You don't want to do that, but if you do, we'll let you do it. And we've also got a series of test functions on there. But for our keypad intercoms and for intercoms in general, there's a lot more settings, as you probably noticed on our device page here. We've, of course, got our volume settings, which we didn't have with our paging series because those just output audio, and the audio is amplified by either the CyberData SIP speakers. They've got their own volume settings, and they can control the volume on their end, or the analog amplifier that is connected to, say, a paging adapter. They've usually got nice volume knobs on there. You want to adjust the volume there. You don't want to adjust the volume on our side, because that also then causes, electrical problems and all that good kind of stuff. But for things like intercoms, where we've got a dedicated speaker on our end, you've got volume settings. And your volume settings are broken out into individual things. So your SIP volume, which would be used in calls, can be set to one value. Your multicast volume, so things like, your warehouse page, your all-call emergency, all that kind of stuff, is set for, your multicast volume there. You've got your ring volume that's used with Night Ringer. Didn't really cover that. We've got a whole other video on that subject. Sensor volume that we discussed at length, push-to-talk volume, and your microphone settings. So you can control every instance of how volume is used on our devices. As we move over to the right, we've got a much more verbose relay setting section where you can, of course, enable or disable the relay activation with a DTMF code. But then you'll see 3 different settings there. We've got our relay pulse, we've got relay activation, and relay deactivation. And I couldn't tell you how many times during initial installation we get calls from customers saying, hey, your intercom's not working right. My door won't lock. And it's like, oh, all right, well, That's kind of weird. It's supposed to lock. Are you sure everything's wired up right? Yeah, okay. Well, that's cool. So how did you unlock your door? Oh, we used the relay activation code. I'm like, okay, what code did you use? Oh, 456. Oh, well, that's relay activation. Well, yeah, we wanted to unlock the door. Well, no, relay activation is very literal. As you'll notice, as you might have noticed as we've gone through some of these settings are they're very literal in their wording, where relay activation means literally that. You enter in 456 while you're in a SIP call, and that will activate the relay. It's not going to deactivate it because that's the relay activation code. If you want to deactivate the relay, you need to call the intercom and you need to enter 654. And these are just defaults. We recommend changing these, but they're very literal meanings to the actual names for the settings, where relay activation and relay deactivation do just that. They activate the relay and they deactivate the relay. If the customer, and most of these, they kind of laugh at themselves when we tell them this. Oh no, you used the wrong code. You need to use the pulse code, which pulses the relay temporarily. And by default, that would just be code 123, and it pulses the relay for 2 seconds, meaning that it activates the relay for 2 seconds, and then after 2 seconds, the relay unactivates. So it just temporarily activates the door, which is what most people are looking for. I don't handle support calls as much anymore, but we used to get a couple of these a week. So it's just kind of one of those things. Oh, I'm really sorry. You probably used the activation code. It's kind of a misnomer. You explain it to the customer. They laugh and they're like, okay, great. We're all good to go. Thanks for making a cool product. But we've got some other settings that you might want to use with your relays, things like play tone during DTMF activation, which is one that, a lot of people end up using, which all it does is when the relay pulse code or the relay activation code is sent and that relay is closed, meaning that it's activated, it will play a tone. So if you think back to those movies that, they've got that guy that's up in his apartment building in the Bronx and, hey, buzz me in. And okay, they press the buzzer on their intercom system and then it cuts down to the guy at the door and he's trying to open the door. Oh, you didn't buzz me in. Well, it's not playing that tone. So what that does is it just plays a tone. So, when your pulse code is entered, it just, plays kind of a consistent beep tone for that duration of the pulse. So that makes it really useful. You can also activate your relay in a lot of other things where, for example, you could activate the relay on button press. So you've got your intercom, somebody walks up and presses the button and it just unlocks the door. Frankly, I don't know why we have that. You might use that for things like a call button or something like that. I wouldn't want to do that for my intercom that's controlling my front door where, somebody could just walk up as a visitor. What's this do? Oh, it unlocked the door. I'm going to go walk in. You don't really want that, but you can enable that setting if you want. Of course, we've got clock settings on here. We've got clock capability or NTP, Network Time Protocol capabilities on all of our products. And this is actually important when you're dealing with our keypad intercoms because they've got the key code entry, again, something we covered in a whole nother CyberSchool, spent an hour talking about that one. But the time is absolutely crucial because you can set your key codes to only work in a specific window of time or only on certain days. And if the intercom doesn't know what day it is, it doesn't know what time it is, your code might not work when your code should work because it's Monday morning at 8 o'clock. And then, Dave is going to be shaking his fist at you. Oh, well, my code didn't work. Well, why not? I don't know. And then they check it. Oh, it wasn't able to sync with the time. The intercom thinks that it's 1986. That's a problem. So things like clock settings are super duper important, which is why as we move to our new platform that we're on, we just have that enabled by default. That way, if it's just set to, West Coast time, at least they can just go through and change it. And then finally, we get to our miscellaneous settings as we kind of round everything out here. You've got different real device-specific settings. So the key ones that I'll highlight are just auto-answer incoming calls. For some reason, if you want to call your intercom and then you want somebody to have to press the button to answer it, you can do that. And then we've also got a ringback tone. So that way, when somebody walks up to the intercom and they press the button on the intercom, they're not just standing there waiting for somebody to answer and say hello. The intercom will actually ring at them, so that way they know, hey, the call's proceeding, it's ringing, I just kind of got to wait and see what happens. So those are two key features that we'll commonly use on intercoms. Another key one that I didn't highlight is just prevent call termination, which is really useful in certain senses with some of our intercom products where if that thing's pushed, Maybe you don't want, somebody to actually be able to cancel that call from an intercom. Key examples of that would be our indoor intercoms that might be, say, mounted in a patient room where, say, like a nurse could go and actually press that in there, and they've got kind of an irate patient. They're having kind of a manic episode. You don't want that patient to be able to, go and press that call button and end the call, and that way the nurse is stuck in there with that kind of manic patient. You might want to disable call termination there. So that way whoever receives the call ends the call. That way the intercom can't actually end the call on their end. But as we kind of round it out, how should I set up my CyberData device? I mean, to be frank, it kind of depends on the platform and what you're using. I can't really give you a general setup that would work for, say, a paging series product or an intercom or a strobe. They're all vastly different products. They've got different applications and different use cases. So there's no end-all, be-all basic setup that you can use. And for that matter, the platforms are all going to be different. You're going to use a vastly different setup for something like 3CX or Cisco Call Manager than you would for, say, Ring Central or Zoom Phone. So it really kind of depends on the platform and the product that you're setting up. SIP registration credentials are all that's necessary for a super duper basic setup. You're trying to set up a SIP paging adapter. You don't want any of these bells and whistles. You just want to be able to pick up a phone and make an overhead announcement. For all to do that, all you need is that just basic SIP registration stuff. Just that primary SIP server. You plug in all the credentials you got, you're done. With our sensor capability on there, you get a lot of ways to enhance the capability of that existing system. It would be really nice to know if somebody tried to go and take the intercom off the pillar for your front gate to try to get access to steal somebody's Lamborghini. The owner of the company's coming in and he's parked his Lamborghini in there, and you get some thieves that are coming over. I don't want to take that car. Well, you'd like to know if they try to take that intercom off the pedestal to try to go and, actually get in through the gate. You might want to know about that, and things like our intrusion sensor can let you know. And then finally, device settings are super duper unique to each application and use case, and things like volume settings, relay capability, and the clock settings are frankly going to be the most used and the most adjusted on there.
Thank you for watching this edition of CyberSchool. If you have any questions, please get in contact with our sales department. They are available by email at sales@cyberdata.net or by phone at 831-373-2601 extension 334. Please make sure to like this video and subscribe for more content like this from CyberData.